Good morning, my name is Lizette Cruz, and on this presentation I will be talking about my key activity, which was an experiment with centripetal force. So as a brief introduction, the uniform circular motion is formed by a stable trajectory. So in spite of experiencing a normal acceleration, it creates a balance in such a way that the velocity is always directed in the same way as its tangent line. So the cause of the uniform circular motion is called the centripetal force, which can be found in various aspects of our lives. Some include the sun's attracting force, a car making a turn, and the experiment we'll be making. Our experiment will consist on tying an object to a rope on one side and a ball to the other. And because of the centripetal force I will cause, the object will not fall and a uniform circular motion will be created. As an objective, I want to demonstrate the effects that the centripetal force can have. I want to describe the uniform circular motion, and I want to analyze the vectors involved and make conclusions based on them. Materials. We will need a small ball of 20 grams, a thin rope, an object with a larger mass than the ball, which is almost 200 grams, an empty stick in which a pen normally comes in, a chronometer, a notebook, and a pencil. So this was my experimental arrangement. As you can see, I just put the rope inside of the empty pen. I tied the small ball to the one side of the rope, and on the other side, I put the heavier weight object, which was this tiny weight. On the left side, you could see that I put it in a more illustrated way so that you can understand better. So, as taking account the methodology, I will make the artifact, which I would explain to you, and then I will let the ball go while grabbing the stick with one hand. Of course, I repeated this and the ball, in fact, fell. After this, I will try again, but instead of only letting it go, I will apply a circular force from the pen, and I will try to make the ball spin. The string will have a radius of 15, 17, and so on centimeters, and then I will time how much it takes for the object to spin 15 times. Afterwards, I will compare the experimental results with the theoretical ones. As you can see, I use this formula of the centripetal force, and then I just balance it out the equation so that I could take the time. So these are my measurements of the experimental part. As you can see, the radius is the x variable and the time the y, making it the independent one. I always analyze 15 revolutions. That's important data to remember. So in analysis, the first graph is showing the time on radius just so that you could see it more vividly. And then I have just the results I got from taking the time from a theoretical way, and then I just illustrated it the same way as the other. We can definitely see that it has a similar tendency to increase, and it's a lot more stable. So to conclude, we can reach to the conclusion that in centripetal force problems, we can make our lives simpler by just taking the measures of stable variables and calculating what we do not know with formulas. Because the action occurs so fast, getting an accurate result is extremely difficult, and taking the time by itself is very unreliable. Other variables that might have modified the experiment is the amount of force I applied when spinning the ball, which could have varied in between my tries. If I were to repeat the same experiment, I'd use measuring apps, and I do the exact same variable several times to obtain an average to make sure that what I got would be really correct. So this is microbiography. Later in the video, I will show you a brief take on how the experiment went. Thank you.